Don't assume that I'm right.
No.
Well, okay, well that's the
That's her character. That's her tragic
So you that people are right.
Hermione.
Commercial.
Hermione. Hermione.
Commercial.
Commercial.
What if we all just oh my god, if we all announced it for Red Rock, how annoying would she be?
I think she's annoyed every time I speak. So probably better. Same. Honestly, same. I think everyone likes her.
You said it, I did.
I get a little bit.
Today sounds
Okay, she's okay.
Sometimes my safety is
turn my brain back when we do this.
All right. So how did number 1 go?
fantastic.
Fantastic.
I could
So
not find
17 pi over 7. Oh, what quadrant? Oh, she's not here.
Oh.
one.
I was just figuring she was here.
First.
Abby, we're gonna go with you since you sit right in front. What quadrant would 17 pi over 7 be in? The first quadrant. So 7 is a little harder to draw. That's not so bad.
Whoa. Come on.
So if we draw an angle in standard position, it should start on the x-axis.
Ouch.
Rotating around halfway is 7, all the way is 14. And then it just barely makes the first quadrant, but it is in the first quadrant, just barely. What are 2 different ways that you can find the reference angle? Maya, one way?
Count the
Yeah, count the sections of the pie. 1, 2, 3. So the reference angle, it says sketch it or label it. So it's the angle that's always positive. Takes you from the terminal side of the angle and the x-axis and it connects them. So one way is just counting. 7 pi or 3 pi over 7. What would be another way you could find the reference angle? If I said don't draw the diagram and just find the reference angle, how would you find it? Chicken?
You would do 17 pi over 7 minus 2 pi.
Yeah.
14 pi over 7.
Minus 2 pi, and he said 2 pi is really 14 pi over 7. And when you subtract, you get 3 pi over 7. That tells you how far past 2 pi you've gone. So that the distance you're passing 2 pi is also the reference angle. So that would be 3 pi over 7. Any questions on the first one? All right, so 2 and 3 I think are the more difficult problems on this page. And it's like getting your brain to remember what you're trying to solve for. And you have to go back and also think about the unit circle. So find all solutions for theta in degrees, 0 to 360, that satisfy the cosecant is equal to negative square root of 2. If you're finding theta, what are you finding? What is theta? Allie? The angle. How many solutions will you have when you find an angle for cosecant? Maggie? 2. So you're either going to have 2 or you're going to have 4. I would have 4 if it said negative 360 to positive 360. There will never be one answer because each function is positive in 2 locations. So we're finding, when it says all solutions, we're really finding 2 angles. That would be the solution because that's the missing part. We don't know the angle, and the angle is like our variable. So instead of thinking of cosecant, what would be easier to think about if we're trying to find this problem? Kevin? Yeah, let's convert it to sine. Sine is easier to think about than cosecant. Kevin, what do you do with the cosecant to find the sine? You flip it. So place 1 over it and then rationalize it. And what do you get, Kevin?
Negative square root of 2 over 2.
Okay, negative square root of 2 over 2. So now this is on the unit circle. Square root of 2 over 2. Is that, when you're dealing with sine, x or y on the unit circle? Y.
day.
So sine is the y on the unit circle, and right now our y is negative. So Ellie, what two quadrants is sine negative in the unit circle? Yeah, so we want an angle in 3, and we want an angle in 4 that has this as its y. So if the square root of 2 over 2 is the y value, the x is also square root of 2 over 2. What would the reference angle be? What angle has square root of 2 over 2 square root of 2 over 2? Taylor? 45. So we're dealing with 45 degrees. That's our reference angle. A reference angle has the same value as the angle that goes into the third quadrant. We use this little piece here as the reference angle of 45 degrees. So I have to pass 180 using the reference angle. So if I was in the third quadrant and I'm passing 180 degrees, what is that, Clint? Yeah, so 180 plus 45. So Quinn, that angle in the third quadrant is? Yeah, 225. So that is my angle, 225. The same value as the sine of 45, except it's negative because it's in the third quadrant. So sine of 45 degrees has the same thing as the sine of 225 degrees, but I just have a negative answer instead of a positive answer. And then trying to do the same thing, but getting it into the fourth quadrant. So here's 360. Again, still using 45 degrees. That reference angle helps us find the other angles that is related to 45 degrees. How would I get the angle, Rebecca, in the fourth quadrant? Yeah, take 360. It has to be less than it by 45 degrees. So that angle would be 315 degrees. That was like similar to the last problem on your test that you took last Tuesday. Any questions on that? So find, I'd say, sine or cosine first, or even tangent. And then look, make sure it's on the unit circle. So this square root of 2 over 2 is on the unit circle. It's one of the 3 ordered pairs on the unit circle. That would be a pi over 6, pi over 4, pi over 3. Question number 3 is similar, but it says radians. And this one goes from negative 2 pi to positive 2 pi. So we should have 4 answers. So we need to have 4. When we find all solutions, we should have 4 of them. And it gives you tangent. And the tangent is negative 3.5. Is that number on the unit circle that we have memorized for tangent? No. So Emma, if it's not on the unit circle, how would you find an angle? Ooh, that would be one thing, yes. I didn't think about that. She said we could make it into a fraction and then make a triangle. Yeah, you could definitely do that. That would be one option. Connor, what would be another option?
Well, since tangent is negative, it's going to be in either quadrant 2 or quadrant 4.
So it is going to be in quadrant 2 or 4. So it has to be an angle in 2 or 4. We could draw a triangle and label our sides. That would definitely be an option. How else can you find the angle?
I would say like 3.5 over -1.
You could do 3.5 over -1. Fine.
So could you do where each of the quadrants is like 2 pi, or pi over 2 pi, and whatever, and then do that based on the decimal of pi?
Yes.
Finding the inverse tangent of negative 3.5.
Yeah, I think the easiest thing to do, and nobody is wrong. I was just trying to give you the easy way. You could just take the inverse tangent of negative 3.5. Put it in your calculator. I guess because I don't say round 2 decimal places in this question, nobody wants to use a calculator because you know how much I hate them. I don't know. But Emma's way with using a triangle, you would still have to rely on the calculator. And the way that Maya was saying, like, or the way that Taylor was saying it, at some point you're going to have to rely on the calculator because the only way you can find this angle is by eventually getting to the calculator and plugging it into your calculator. So no matter what method you use, at some point you've got to go back to the calculator and use the calculator because we need to find the angle. And the only way we can find an angle is by using the inverse tangent. So Jacob, what number do you get out of the calculator?
Negative 1.29.
Okay, so negative 1.29. If that's a negative angle, that's this little guy right here. That angle is in the fourth quadrant. Negative 1.29. So that's one answer in the fourth quadrant. I'm only going to focus on the fourth quadrant right now. How can I get the positive angle that also goes in the fourth quadrant? By using this number. So how could I take the number that we got from the calculator and get the angle to go in the positive direction?
Add 2 pi.
Add 2 pi. So the answer from the calculator isn't wrong. It's one answer because I need a negative angle and a positive angle in each quadrant. So if I take that answer from the calculator and add 2 pi, you end up getting, Connor,
4.99.
4.99. So these two angles are the two angles in the fourth quadrant. The one from the calculator is the negative. If I add 2 pi, that gets me its coterminal.
Why are you adding 2 pi instead of taking 1.29 from 2 pi?
You could do that too. It's going to get you the same exact answer. But we need, either way, it's going to give you the same exact answer. So you could take 2 pi minus 1.29 and you're still going to get 4.99. So it just kind of depends on how you're thinking about spinning around the circle. So the other side that we need to think about, Connor said it's positive in 2 and 4. So we have the answers to 4, quadrant 4, both positive and negative answers. But we need to get that angle in the second quadrant as well. That 1.29, the negative 1.29 from the calculator, that's your reference angle. So it happened to be a solution as part of the fourth quadrant, but it's also this little angle right here as well. So the reference angle gets used in different ways. But it's going to help you find the angle in the second quadrant and the angle in the fourth quadrant. How would I get the angle in the second quadrant? Heather?
You use reference angle to subtract that from pi.
Yeah. So right here's pi. I need to be less than pi by that reference angle. So for the second quadrant, he said take the reference angle and subtract it from pi. And that gets you 1.85. Okay, so that's my positive angle. That's this guy right here. And then I need the negative angle. And Quinn, how would you get that negative angle? Say it again. You're so close, but I need to be negative. Instead of positive pi, I could use, so we could use negative pi and then minus 1.29. Because I now need to go in the negative direction, and if I'm going in the negative direction, that now becomes negative pi. What other way could I find it, Maya?
Do 1.85 minus 2 pi.
You could also do 1.85 minus 2 pi. They're going to give you the same answer. Just depends on how you think about approaching it. So Maya, if you take 1.85 minus 2 pi, you get
Negative
4.43, you said, right? And if I do this way, negative pi minus 1.29, do you still get the same answer? Yes. So either way gets you the same two angles. So 1 and 2 for quadrant 2. Question. So I think those were the hardest. The last problem is pretty straightforward. Just have have to remember two little tricks. It has diameter of a circle is 8 inches. Find the length of the arc intercepted by a central angle of 240 degrees. What are you trying to find? Right? The arc length. Maggie, what formula is associated with arc length? The angle and then what? Radius, sorry. So we have an angle that's 240 degrees. Right here's 240. Our goal is to find the arc. It just is worded a little different. The arc of an intercepted angle by a central angle. She gave us the formula S equals the angle times the radius. Connor, what do you have to do here?
You have to convert 240 degrees into radians because theta needs to be in radians for the equation.
Yeah, that formula is a formula for radian measure. That's how a radius or a radian was created, using that formula. So they saw a pattern with taking those values and taking the arc and the radius. And so the formula was created for radian measure. So we need to convert it first to a radian. And Connor, if we cancel out our zeros, that reduces to 4 pi over 3. So that's our angle. The other thing, you have a diameter of 8. You can't plug 8 in because we need a radius of 4. So Connor, 4 pi over 3 times 4. 755. And that's inches. Nice job. Any questions? Say again? You could leave it as 16 pi over 3 as well. You still have to write inches next to it though. But like if somebody was asking you like if the radius around or the arc around the clock or around a bicycle, you'd probably convert it to decimal values so it makes a little more sense. But no, you wouldn't have to leave the pi in. Other questions? Is there a problem from the homework that you wanted to work through? Like the graphing homework? 7? I'm going to go through the first part of 7 pretty quickly. So if you want to look at your number 7, we'll go through all the pieces. And then I think the labeling of the graph in this one is a little tricky. It's a really long period. So this graph gets stretched. It's pretty wide. Again, this is number 7 from the homework. So A is 2. I know that's going to find the amplitude, also 2. B is 1/3. So remember, you're dividing it by 3. B is actually 1/3. So your period is 2 pi. And if you divide that by 1/3, you get 6 pi. It's tripling the length of your period. Usually it's 2 pi, and then I got 4 pi and 6 pi, so we're like tripling that amount. Before we move on to C, we have to count by 6 pi over 4, which is, Kevin, 3 pi over 2. So we are going to use 3 pi over 2 as increments. Again, usually it's pi over 2. So we're expanding the period, we're expanding the distance between the 2 points. Kevin.
So I counted, made each individual tick mark on the graph, pi over 2.
Yep.
Could that work?
Yeah, that's what I did as well. Yep. C is negative 2 pi over 3. And that helps us get the phase shift. And that phase shift is important because that's where the graph starts. So if you take C and divide it by b, the graph is starting at negative 2 pi. So it starts at negative 2 pi. You're moving by 3 pi over 2. Like those would be two important pieces of information. The last part is that d value. That just shifts the graph down. That's the sinusoidal axis. It's the vertical shift. So the center of the graph should be down below the x-axis instead of at the x-axis. I'll use that number last. So if we start with negative 2 pi, add 3 pi over 2, that then gets you your next point. So I'm at negative 2 pi and 3 pi over 2 make negative pi over 2. And then again, add 3 pi over 2, Emma, so then you're at pi. So you can see, like, the distance in between those is pretty big. So negative 2 pi to negative pi over 2. Like, that's pretty spread apart compared to what we're typically working with. And then, Emma, if I continue to add 3 pi over 2, we get up to 5 pi over 2, and then 4 pi. Easy way to check yourself. What's the distance from negative 2 pi to 4 pi? What's that whole distance? 6 pi. If it doesn't match with what you said your period was, you probably didn't add something correctly. But the distance from negative 2 pi all the way to 4 pi, so negative 2 pi and 4 pi, that entire distance is 6. If it doesn't match, then you didn't add something correctly to get to the next point. Questions on that? The last part here, getting y. I know this is cosine. Cosine usually goes 1, 0, negative 1, 0, 1. I have to multiply by 2 first because the 2 is in front. And then you subtract the negative 2 last. So I would subtract 2 last. If you need to do it in separate steps, that's fine. But if I'm multiplying by 2, I would have 2, 0, negative 2, 0, and positive 2. And then I have to subtract 2 to those y values. Order of operations, multiplication first, subtraction last. So if I subtract 2, this is now 0, negative 2, negative 4, negative 2, and 0. It never goes above the x-axis because the graph is shifting down. Questions? So Kevin said he counted by pi over 2. This is a really long period. So each one of these little boxes on the graph has to be pi over 2 so that you can fit 2 periods on your graph. So this is negative pi over 2. And then I have 2 pi over 2, 3 pi over 2, 4 pi over 2, which is negative 2 pi. Those would be my first 2 points. But then I need to move the other direction because my next value is pi. So again, pi over 2, 2 pi over 2 is pi, 3, 4, 5 pi over 2. And then 8 pi over 2 is 4 pi. So if I look, like I still have 3 spaces in between each box, or in between each ordered pair, in between each tick mark, however you want to think about it. It's still equally spaced so that my distance in between is the same. And we're going down to negative 4. So I'm starting at 0 for negative 2 pi. And then we're going down at negative pi over 2 to negative 2. Down even further, and I didn't count right there. That's it. So at pi, we're going down all the way to negative 4, and then I should start moving back up. That is 1 period of the graph, and it's a pretty wide distance from the start to the stop. So you're asked to graph 2 full periods. I don't have as much space over here as I do on the other side, so I'm just going to graph my second period going left. Counting over 1, 2, 3, putting a little tick mark. And I actually run out of room. Just trying to make sure that it's equal distance in between. So 3 blocks in between each tick mark, and then continuing back down. And it should end up at the highest point because it's cosine. So my original, and then my second period I graphed on the left side. When you look at your little tick marks before you start plotting the points, make sure the distance between each of those is the same. We're going to come around and check that. Are there questions that you have?
Can you just look at the graph and look at it, or is there a number, period is
Yes. So looking at the graph, you can see that from the middle to the top is two distance value. Yeah. And that's what we'll be kind of talking about like as we move forward. So if you look at page 25 in your packet, you're skipping a ton of pages.
Oh, yeah.
We're going to do those eventually. So what the pages that you're skipping are taking a graph and trying to write an equation from the graph. So if I had a picture, can I try and create the equation from the picture? And then you're also skipping some application problems that we're going to come back to. So trying to write equations from word problems. So if I have a clock, can I write an equation for a clock? Can I write an equation for a tidal wave? Can I write an equation for like a windmill kind of spinning around? We're going to talk about that. Yeah, there's a Tarzan problem. So if you're swinging, we can write an equation for you swinging in your backyard. Going back and forth. So we'll be like talking about writing equations like that. But on page 25 is the start of reviewing numbers 1 through 10. And there are still a couple of you that may want to do a problem for tomorrow.
I'll do one.
Okay, so what on? Maya, 7, 8, or 9?
Oh, I have to. Let's go 7.
I did.
Oh.
Ellie? 8. Dylan?
9.
9? Awesome.
Wow.
That's pretty good.
In order.
How about that?
Look at that.
Perfect. Okay. So get to work on page 25, looking at those problems.
Yeah. Homework wise.
I'm going. I'm right in there.
Number 4. I just don't know.
And then you have your calculator key. Yes. So like this point is important because that's where you start. That's where you
I think I'll get 15. Yeah, I found like
Yeah, those are good. So it's the beach shift where it's like throwing you off.
Yeah, well, like as we were going through it, number 8, it was just. I think I accidentally mixed these two equations.
Yes.
Yeah.
You're combining two different things.
Yeah, and that's where it was wrong. But yeah, I think
This is good. And here I have my normal summer just I need your Y back. Like you do your steps. Yeah, like write the original and then yeah, I just
Cause I'm just trying to do it like how you do
Yeah.
it, but I think I.
like even if you just write it like I have the 2 0 and then I just cross them off and wrote
Yeah.
down consonants.
Because I don't like movies.
So they have to be right
Wow.
something like that.
So you never have to and we kept giving you the same.
That is the correct thing because this is a reference angle. All the revisions are based on
See?
so they're all related.
Nice.
Well, if you try. Oh. So 15 would be
Okay, I get like that, but like.
It's, okay, so it's two triangles would be 15 plus that, right? That's right, so it's- so from here to here.
Yeah, but what's the whole thing with the
You could do 2 pi minus 5 over. That would be 30. Oh, no, no. You could do.
Oh, I know why you can't do that, cause it's not a full cycle, cause
Yeah.
15 is the 12.
Yeah.
I zoned out, okay.
Yeah, yeah.
At least I can answer that right.
Oh, shoot.
It takes me a little bit, but.
What?
I know how to do all that. The graphing I just have to.
And, oh, my.
Well,
Sorry, you did. What'd you get? Oh my god. Mine was better than yours, so I hope I got it. If I don't get 100, I'm mad. I practiced so many times that. What? I didn't know. I thought we only had to do 2 of them. Like, same. Which is why I was not ready to go first. I'm not good at tricks because I didn't know.
Wow, what a, that's, that's pretty unexpected. What's that?
Tomorrow night I volunteer.
A lot of people do that. And you don't expect it, so I just expect everyone to do what they do. You can't be surprised. Don't be suspicious. It's not his able to on Sunday, and I immediately thought of you.
I asked someone what the nomination was, and they said pescatarian.
Pescatarian? Wait, what?
Not a fantastic
The
say.
combination. Pescatarian is someone who eats fish. Like a vegetarian.
Oh, I didn't make yesterday, and then like 5 days. Well, I was in homework, because I was so out of it. I had like
So if I graph this, that's here.
I really should know. I had like 2 graphs.
So if I graph
I was
this,
like, we had
it's
3
the
homework
exact
assignments.
same value as this.
I have a lot. Wait, there's
And
nothing.
it's positive because
Wait, no, I can grab it.
same thing with this one,
Wait, dude, that's
now
really
down
okay.
here.
So I have like a playlist on Spotify that I listen to like it's 2 hours long. And I was listening to it and I was like,
Negative because
this is done already?
third.
I only did like 2 math problems.
When you notice about 65.
My mom was like, so this is Bye Taylor.
So everything is based off of that. Even weird to think about. Just try and get you to see the relationship. Figure. Kevin, I hope you start feeling better soon.
I think I'm getting better.
Yeah? Okay.
I'm not as sick as I was yesterday.
Oh, that's good.
Like I'm a little out of it, you know?
Yeah. No, yeah.
Like my brain is foggy.
Mm-hmm.
It's like, I don't know, it's like really weird. I was out of it in chemistry today. Like I was really tired. But in math